Hi, ladies and gentlemen. Mrs. LaJoy here. Today, I just want to go over kinds of triangles and quadrilaterals. So, first of all, types of triangles. So, I've already drawn them out here. This first kind of triangle is called a scalene. Properties of a scalene triangle are that no sides are equal. So, we have no equal sides. And no equal angles. So the markings show us, we could also have markings here to show us our angles. So we've got this one, and this, and this. So all these angles are different. All of the sides are different. Okay, so nothing is equal in a scalene triangle. The next kind is an isosceles. Isosceles. Now, characteristics of an isosceles triangle are that we have two equal sides. And we have two equal angles. Oops. And our side markings show that we have two that are the same and one that is different, and our angle markings would look like this. Okay, so that shows that these two angles are the same and one angle is different. Next kind of triangle is an equilateral. Running out of space, but so an equilateral triangle, we have three equal sides and three equal angles. So again, all of our sides will have the same marking to show that they are the same, and same thing with the angles. Okay, and the last kind of triangle is the right angle. And the right angle triangle has a 90-degree angle. All right, so those are our kinds of triangles. I need you to know that angles in a triangle add to 180 degrees. So for example, if we have this triangle, and we have side A, or angle A, angle B, angle C, and we don't know what this angle is, but it tells us that this one's 45 degrees, and this one is 50 degrees. We can find the missing angle because we know that the triangle will add up to a total of 180. So to find our missing angle, we could say x plus 45 plus 50 equals 180. And to figure that out, we will isolate for x. So x equals 180 minus 45 minus 50. And of course, x equals 85. So that means that our missing angle is 45 degrees. Now I want to look at the angle theories. So let's clear this. So we already know that the sum of the interior angles is 180 degrees. Now, we need to know that the sum of the exterior angles of a triangle is 360 degrees. So the sum of exterior of a triangle is 360 degrees. So just like we found the missing angle inside the triangle, we can find missing angles on the outside of a triangle. So let's look at an example of that. So if we have a triangle here where, let's see, okay, and actually, so here's our triangle, and we can label this as A and B and C, and I'm also going to put this up here as D and E. Okay, so if we want to find, let's add in some information on this triangle here. So let's say that this angle out here is 130 degrees. And we'll say that this angle down here is 138 degrees. And we want to find this angle right here. So we've got an X there. So let's see here. So information that we have is that angle CAD is 130 degrees, right? CAD is 130 degrees. And we have angle, oh, I gotta put this down here too. And angle FCB is 138 degrees. We are looking for angle ABE. Well, if we know that the exterior angles of the triangle are going to add to 360, we can find our missing exterior angle. So I'm going to say X plus 130 plus 138 equals 360. So X plus 268 equals 360. So we move the 268 to the other side. 360 minus 268 So therefore x equals 92. So therefore x equals 92 degrees. And we can say that angle ABE is 92 degrees. Okay, so we know that the interior angles of a triangle are going to equal 180 degrees. So what if you're faced with a question that looks like this? So for each of our angles, instead of just having an amount of what the angle measures, we have little equations. So how can we figure out what our x is equal to? Because once we know what x is equal to, we can figure out the measure of our angles. So how do we find this out? Well, we know that the entirety inside this triangle is going to equal 180. So if we put all of these together, we know they're going to equal 180. So let's see. So if we have 7x plus 36 plus 5x plus 2x plus 4, all of that together equals 180. So let's solve for x. So combine our like terms. 7x plus 5x plus 2x is going to be 14x. And 36 plus 4 is 40 equals 180. So 14x plus 40, so we'll move that 40 to the other side. 14x equals 180 minus 40. 14x equals 180 minus 40 is 140. How do I get x by itself? Divide both sides by 14. So we're going to end up with x equals 140 divided by 14, 10 degrees. Okay, so our x equals 10 degrees. How can we test this out? So for each of these angles, we're going to plug in 10 for x and solve. So let's see, the first one up here, we have 7x plus 36. So 7x plus 36 is going to be 7 times 10 plus 36. So that is 70 plus 36. This angle is 106. Okay, so this angle equals 106. That's that one right there. Okay, this one over here, let's move it over this way so we have some room to do it. Okay, so we've got 2x plus 4, 2x plus 4, so that's 2 times 10 plus 4. 2 times 10 is 20 plus 4 equals 24 degrees. So right there, 24 degrees. And then we have this one right here, which is going to be 5 times 10. Oops, I should have written 5x, which is equal to 5 times 10. 5 times 10 is 50 degrees. So if we add all of them together, we should have 180. So 106 plus 24 plus 50. 106 plus 24 plus 50, 180 degrees. All right, the properties now of quadrilaterals. So I've already drawn these out for us. Quadrilaterals are geometric shapes that have 4 sides. So triangles have 3 sides, quadrilaterals have 4 sides. You can remember that as quad, which means 4. So let's see. Our first one, fairly obvious, is a square. So a square is going to have 4 equal sides. And 4 equal angles, 4 90-degree angles. You'll also notice that we have these 2 sets of parallel lines, right? These are marked as parallel, going horizontally, and also the vertical sides are marked as parallel. Next one is a rectangle. So like the square, we have 4 sides here, but we have 2 sets of parallel lines. So I've got horizontal and vertical parallel lines. It's important to know that the opposite sides are equal. And we have 4, again, 90-degree angles. All right, the next one is a rhombus. R-H-O-M-B-U-S. So a rhombus has 4 equal sides. And opposite corners are the same angle. Same angle. This one here, after the rhombus, is the parallelogram. Now the parallelogram is going to have opposite sides that are equal. And we have the opposite corners are the same angle. Okay, last one up the top here is the trapezoid. Trapezoid has 2 parallel sides. Oops, not writing great tonight. Down here we have a kite. Now the kite has adjacent sides that are equal. And we also have 1 pair of equal angles. Okay, last one here is just a quadrilateral. And it has 4 sides. So we don't have any parallel lines here. We don't have any equal angles, but it does have 4 sides, which means it classifies as a quadrilateral. All right, so part of the properties of the quadrilateral that we need to know are that the angles in a quadrilateral, so the interior angles, equal to 360 degrees. So interior and the interesting thing about quadrilaterals is that also the exterior angles in a quadrilateral equal 360 degrees. So let's look at two examples. All right, so this first quadrilateral, we want to find the measurement of the missing angle. So we have the other measurements of 70, 140, and 85. So knowing that it's going to equal 360, just like we did with the triangles, we're going to put this all together here. So x plus 140 plus 70 plus 85 equals 360. So again, we want to isolate x. So I'm going to move everything to the other side. So we have 360 minus 140 minus 70 minus 85. So when we take 360 minus 140 minus 70 minus 85, we should have x equals 65 degrees. So that makes our quadrilateral because all of those angles are going to equal to 360 degrees. Let's do another example. Now for this quadrilateral, we are going to look at the exterior angles. So we're trying to find the measurement of this exterior angle here, that's x. So we know that the exterior angles are going to equal 360. So just like I did in the last one, I'm going to take the angles that I have on the outside of this quadrilateral. So I have my x, my unknown. What do I have? I have 135. So x plus 135 plus 95 plus 102 equals 360. Once again, I want to isolate for x. So I'm going to move everything else back over to the other side. So x equals 360 minus 135 minus 95 minus 102. So 360 minus 135 minus 95 and minus 102 would give us 28 degrees. So our missing exterior angle is 28 degrees. Okay, let's look at something that's a little more complicated. And this could work the same way with a quadrilateral. But we have two triangles here, and we have a bunch of unknowns. So what we need to do here is figure out the value of x and y. So if we look at the first triangle here, we just have x's as our unknowns. In the second triangle, we have a y. So we're going to have to figure out the first triangle. Let's label them 1 and 2. We're going to have to figure out the first triangle so we can figure out the value of x, because that's going to apply in the second triangle. So in this first triangle, we want to recognize that, again, the interior angles of this triangle are going to equal 180 degrees. So if we put all of these together, they should equal 180. So we have x plus 7 plus x minus 9 plus 3x minus 18 equals 180. So again, first we want to combine our like terms. So we have x plus 3x. So we have a 5x. And then we have 7 minus 9 minus 18. So 7 minus 9 minus 18. So we have a negative 20. So 5x minus 20 equals 180. We want to isolate for x. So I'm going to move this negative 20 to the other side. So I get 5x equals 180 plus 20. 5x equals 200. Now to get x by itself, I'm going to divide both sides by 5. And I have x equals 200 divided by 5 would be 40. So that tells me that the value of x is 40. Now we can test this out by plugging 40 in for each of our angles. And if we have what equals 120, we have done this correctly. So let's see. So we want to test this out with x plus 7 is the degrees of this first angle. Well, if x is 40 plus 7 equals 47 degrees right here. Okay, this one up here, we have 3 times x minus 18. So 3 times 40 minus 18. 3 times 40 would be 120 minus 18. 120 minus 18 is going to be 102. So 102 degrees right here. And the last one, x minus 9. So this one here would be 40 minus 9. 40 minus 9 would be 31, so equals 31 degrees. So this angle is 31 degrees. Okay, so 47 plus 102 plus 31. So 102 plus 47 plus 31. That equals 180 degrees. Okay, so we've done that first triangle correctly. We know that our x is equal to 40. So I can apply that now in this triangle. So if I can plug in and figure out what these two angles are, I can figure out what my unknown angle is, my y. Okay, so let's use 40 for these as well. So same thing we just did over there. So I have 40 plus 21. 40 plus 21 is 61. So this angle is 61 degrees. This angle right here, we have 40 plus 17. So 40 plus 17 would be 57. Right there. So the two angles that we have in this triangle are 61 and 57. We know that the whole triangle has to add to 180 degrees. So we can put in our y, our unknown angle, plus 61 plus 57 equals 180. Let's find the unknown. Isolate for y. So 180 minus 61 minus 57. So 180 minus 61 and then minus 57. 57. Y equals 62. And again, if we add those angles up, we have 61 plus 57 plus 62. 61 plus 57 plus 62, yes, is 180 degrees. So once you know what your angles add to, whether it is a triangle or a quadrilateral, you can find the measures of the unknown angles, either interior or exterior.